Assalamu alaikum. By the end of this video, you will be able to understand the concept of real numbers and its subsets and able to identify classification of numbers. Let's begin. There are many numbers. Some are fractions, some are positive numbers, some are negative, some are perfect roots, and so on. Mathematicians classify these numbers as natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Let's learn this classification one by one in detail. The first one in the classification of real numbers is natural numbers, which is also known as counting numbers. And the Arabic translation of natural number is mentioned here. What are the natural numbers? It is denoted by N. It is denoted by capital letter N. Starts with 1 and continue. The set of natural numbers is 1, 2, 3, 4, 5, dot, dot, dot. This dot, dot indicates that the numbers after 5, which are 6, 7, so on. So the set of natural numbers starts with 1 and continue. This numbers is also known as counting numbers. Because see how we will count. If you want to count the chairs in the classroom, we will count as 1, 2, 3, 4, 5, 6, 7, and so on. This counting we are starting from 1. So this numbers, natural numbers, is also known as counting numbers. I hope it's clear for you. Next is whole numbers. See the Arabic translation of it. This is the Arabic translation of whole numbers. It is denoted by, you can see the Arabic translation for denoted. This is the Arabic translation. It is denoted with W. Starts with 0 and continue. The set of whole numbers starts with 0 and continue as 0, 1, 2, 3 and dot, 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 dot. Indicates the numbers after 5. So here if you see carefully, here from 1 to above the numbers, these are the natural numbers. Natural numbers plus 0, which is nothing but the whole numbers. So here try to understand, this is the set of natural numbers which are all positive numbers also can be say 1, 2, 3 so on. This is the set of natural numbers. If you add 0 to it, it becomes the whole numbers. Okay. Now this is also, we can write it as the relation between natural number and whole number is N is the subset of whole numbers. N is the subset of whole numbers. What is the symbol? This symbol is nothing but the subset. This symbol. Okay. You can see the Arabic translation of it. Subset. Subset. Subsets are sets and subsets with examples are well explained in the video Sets, Cartesian product and relations with Arabic translation. Watch that video to get the complete understanding of subsets. So this here, N is the subset of W. Natural numbers is the subset of whole numbers. Okay. I hope you understood. Let's we move to the next one. Integers. This is the Arabic translation. Integers. Integers, it is denoted by Z or Z. Here in the integers you have all the negative numbers, 0 and all positive numbers. 0 and all positive numbers. All negative numbers, 0 and positive numbers are the integers. The set of integers are the numbers before minus 3, it is written as like this: the numbers before minus 3 dot dot dot, and 0 and 1 2 3 and dot dot are numbers after 3. So this, the set of all the negative numbers, 0 and positive, is called integers. Here this is the set of integers. This is the set of integers where you can find all the negative numbers, 0 and positive. So if you subdivide in this one, this 0, 1, 2, 3, these are the whole numbers. And again, if you subdivide the all positive numbers, which are 1, 2, 3, are the natural numbers, and the complete set is the integers. So this relation can be described as n is subset of w and w is the subset of z, and this is the symbol for the subset. This is the symbol of subset. Now let's move. I hope these three classifications you understood: natural numbers, whole numbers and integers. Next is the rational number. It is denoted by Q. This is one of the big set. It is denoted by Q and written in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is very important. We will write the numbers in the form of P by Q. Are the rational numbers. Example: 5 by 2. 7 by 3. What is in the 5 by 2? 5 is an integer, 2 is an integer. If you write 5 by 2, it becomes a rational number. 7 by 3 is a rational number. 22 by 7, 12 by 6, these are the rational numbers. See, this 12 by 6 is an important number. Try to understand this 12 by 6 we can write as also as 2. This 12 by 6 we can write it as 2. So this means 12 is also a rational number. Similarly 3 is also a rational number. 3 can be written as 3 by 1. Therefore 3 is also a rational number. Root 16. Try to understand here, the students will get confused. Root 16. Okay, root 16 is also a rational number because it's a perfect root. Root 16 is a perfect root which is equal to 4. So all perfect roots are also rational number. All perfect roots and integers are also rational numbers. Now very important note that you have to remember here in the rational number is every rational number can be written both as ratio and as decimal. That either terminate, stop, or recurring. Recurring means repeat. So this try to understand with an example. See, a 3 by 4 is, we are writing in the form of ratio. This is a ratio. 3 by 4 is a ratio. This 3 by 4 can be written in the form of decimal as 0.75. 3 by 4 is equal to 0.75. This is here terminating. Terminating means stop. After decimal, the numbers stop. 75. 3 by 4 is equal to 0.75. And 1 by 2 is a ratio, can be written as 0.5. So here the stops. The first example, the decimal that stop. These are the two examples. I hope you understood. So next is, if you see 1 by 3, 1 by 3, if it, this is a ratio, can be written in the decimal as 0.3333 and dot dot. Means here after 3 it's not stops, it goes on 0.3333. It will not stop, please. So these numbers are called not recurring, repeat numbers. Repeat. It will repeat again. So here the decimals you can write either terminating means stop or recurring, and repeat. The number is repeating here. So this 0.333 can be written as 0.3 bar. What is this? Bar. We have to read this as a bar. The bar above the number indicates that it repeat, it recur, again is come. This bar, okay, indicates that it repeat. 0.3333 can be written as 0.3 bar. And another example, 2 by 3. This is equal to 0.6666. Here also the number 6 is repeating. So this can be written as 0.6 bar. 0.6 bar. Okay, so the number repeats. I hope you understood here. The decimal, you can write either in the form of ratio or in a decimal which terminates with stop. 0.75, 0.5. If you take the example of 5 by 2, which is equal to 2.5. Okay, so this is an example of terminating. And another is repeat, recurring, repeat. Example of repeat is this one. Here 3 is repeating, here 6 is repeating. It will not stop, but it repeats. Example 7 by 3, this also number repeat here in the decimal. Okay, 22 by 7, here also the number repeat. Okay, in the decimal, after the decimal. So here these numbers are called the rational numbers. These numbers are the rational numbers. I hope you understood now. So let me move further. So this is the set of rational number. 2.3 means decimal which are repeating after the decimal. 2 by 3 negative numbers, ratio, decimal which stops, perfect roots. Perfect roots even you can write as cube root of 8. We can write cube root of 8, which is also a cube root of 8, which is equal to 2, which is also a rational number. Here the 1, 2, 3 is the natural numbers. If you add 0, it becomes the whole number. If you include negative numbers, it becomes the integer. And the remaining all, if you include even this number, then it is called the rational numbers. Rational number is a very big set. Rational number is a very big set. So the relation between this classification of numbers is natural number is a set of whole number, subset of whole number, and whole number is the subset of integers, and integers are the subset of rational numbers. Up to here, I hope it's very much clear for you. So let's move to the next classification, which is irrational numbers. This is one of the important number. It is denoted by I, letter I. It is a number that cannot be written as the ratio of two integers. This is very important, please. This cannot be written, okay, cannot be written as a ratio. This is very, very important. Try to understand. You cannot write in the form of P by Q. Cannot. Okay, rational numbers cannot be written in the form of P by Q. And the other thing that you have to remember here is decimal form. You can write only in decimal, which is non-terminating. It will not stop. It goes on, non-terminating, and non-recurring. And non-recurring means it will not repeat also. It will not stop and it will not repeat. This is the decimal form of the irrational number. Non-terminating and non-recurring means does not repeat. It will not repeat. It will not stop and it will not repeat. Example, root 5. This is equal to 2.23606 and more numbers are there. It will not stop. It will not stop. There are infinite numbers even after 7. So this is not repeating. You cannot see any repetition of the numbers. Means in a particular order, in a particular sequence. There is no repetition. So this root 5 is a irrational number. Right? Next, another example is root 3. If root 3 can be written as 1.732050.8 It's not stop. It goes on till infinity. So this root 3 is also a irrational number. Non-terminating, try to understand, means it will not stop. It goes on after the decimal. And non-recurring, it will not repeat. No number will repeat continuously. So these numbers are called the irrational numbers. Means here you can say non-perfect root, non-perfect square root, non-perfect cube root. These all are irrational numbers. Any non-perfect square root, any non-perfect cube roots are irrational numbers. And the special numbers like pi and e are also irrational numbers. Here the number will not stop. It goes on after decimal in the pi, in the e. So these numbers are the special numbers, and these are also belongs to irrational numbers. And the set of irrational number is, some example I have taken here, root 7, root 11, pi. These are the set of irrational numbers and many more. Now the last classification in the real numbers is real numbers. It is denoted by R. It includes both rational and irrational. It includes both rational and irrational. For your understanding, one note you have to remember that intersection of rational numbers and irrational number is empty set. There is no number common between rational and irrational number. So here real number includes both rational and irrational numbers. Example, all the positive numbers just I have taken as 99, minus 3 is the negative number, non-perfect roots, decimal forms, okay, negative numbers in a fraction, in a ratio, or in the decimal form, the numbers which repeat, okay, these all numbers are the example of real numbers. You can see here, these are the set of rational numbers. You already aware of this one, all the ratios and negative number 0 and all positive numbers belongs to the rational number. And the irrational number, okay, together it forms a real number. Includes rational number and irrational number. Together it is a real number. Right? Is it clear? So now you understood the classification of real numbers. All classification I hope is very much clear for you. If anywhere is doubt, you can write your comment in the comment box. I will reply inshallah. So now let's we understand this by doing an activity. Now this is the activity. Write the classification one by one. Try to write along with me. Natural numbers. The classification here I have written some numbers: natural, whole numbers, integers, rational, irrational, real. So let's we write one by one. This 9 minus 9 belongs to which number? Is it belongs to natural numbers? Yes? Yes or no? You are right. It does not belongs to natural numbers. Does it belongs to whole number? No, you are right. It does not belongs to whole number also. Does it belongs to integers? Yes, you are right. It belongs to integers. Does it belongs to rational number? Yes, it belongs to rational number. Does it belongs to irrational? Yes? No, yeah, yes, you are right. It does not belongs to irrational number. And of course, all numbers belongs to real numbers. All the numbers belongs to real numbers. So minus 9 belongs to real number. What about 0? Does it belongs to natural number? No. Whole number? Yes. Integers? Yes. Rational number? Yes. What about irrational? You are right. It does not belong to irrational number. What about real? Yes. it belongs to real number. Next, 2 by 3. Does it belongs to natural numbers? No. Does it belongs to whole numbers? No. Does it belongs to integers? No. What about rational? Yes, you are right. It belongs to rational number. What about irrational? Yes, it does not belongs to irrational number, and it belongs to real numbers. Of course, all numbers belongs to real number. What about 11? Yes, natural number. It's a whole number. It's an integer. It's a rational, but not irrational. But it belongs to real number. What about root 5? Root 5 is not a natural number, not a whole number, not an integer, not a rational. Yes, but it belongs to irrational. And of course, it's a real number. 3.5. 3.5 is not a natural number, not a whole number, not an integer, but it belongs to rational number and does not belongs to irrational number, and it is a real number. What about root 9? Concentrate here. Root 9. Root 9, here the students will get confused. Root 9 is nothing but 3. So 3 is a natural number. Root 9 is a perfect root. Root 9 is a perfect root. So just perfect roots, you have to belongs to the rational number. So now see here, 3. 3 is a natural number. It's a whole number. It's an integer. It's a rational number, but not irrational. And it's a real number. And 3.5146 ... This indicates the number after decimal is not stop and does not repeat. So these are not a natural number, not a whole number, not an integer, not a rational, but it belongs to irrational number. And of course, real number. And here if you see, here the number of 3 bar, means 3 is repeating here, 2.523 bar. Bar is about the 3. So this indicates that it belongs to the rational number, but does not natural number, not a whole number, not a integer, but it is a rational number and not a irrational. And it belongs to real number. I hope you understood all the classification of the real numbers. Now try this 2, -5 and pi. This was about real numbers system. Hope you enjoyed. Watch another video, properties of real numbers with Arabic translation, which is the basic and important for understanding algebra. Link is provided in the below description box. Thanks for watching.